Isomerism in complex compounds. We know isomerism in organic compounds, right? Cisterns in organic chemistry, cisterns is a dissonant geometrical, right? And optical isomerism, enantiomerism, diastereomerism in first year organic chemistry. Similarly, in complex compounds, in inorganic compounds also we can see the isomerism, but the concept is different. Okay, concept is different at the geometrical isomerism. Optical is common concept only, that is symmetry element is the concept, right? I'll give the introduction before entering into the particular isomerism, right? I'll revise the basics also. Let us start. Isomerism. What is the basic definition of isomerism? The compounds having same molecular formula, but different structures. Simple definition. Once look at this, CH3OCH3. I'm taking organic molecule example, right? Later coming to the complex compounds. Once I am revising isomerism definition. What is the molecular formula for this? What is the molecular formula? How many carbons are present here? 1, 2. 2 carbons and 6 hydrogens and 1 oxygen. Here also same only na, C2H6O. Both are having same molecular formula. But this structure is different and this structure is different. In this structure, one oxygen is connected to 2 carbon. This side 1 carbon, this side 1 carbon. Here one oxygen is connected to 1 carbon only. Structure is different. Differently appearing or not? Different structures. So compounds having same molecular formula with different structures are called as isomers, and the phenomenon is called as isomerism. Compounds with the same molecular formula with different structures are said to be isomers, and the phenomenon is isomerism. Right? This is in first year. Okay, this definition and this concept. Right? Okay. Coming to isomerism in complex compounds. Isomerism in complex compounds. Here also definition is same. In complex compounds also, complexes with the same molecular formula with different structures, or complexes with the same molecular formula or different optical rotations. Same concept is same. If I give 2 complexes, when we call the 2 complexes isomers, they should have same formula. For example, look at this, CONH3 taken 5 ClSO4, CONH3 taken 5 SO4Cl. Both complexes are having same formula. Why same formula? 1 cobalt, here also 1 cobalt. How many ammonia? Amine ligands, sorry. How many amine ligands are there? 5. Here also 5. How many sulfate ions are there? 1 sulfate ion. Here also 1 sulfate ion. Here how many chlorides? 1. Here how many chlorides? 1. So same molecular formula. Complexes are having same molecular formula, but what is the difference? Difference in the structure. See, in this coordination sphere, chlorine is there, but in this coordination sphere, sulfate ion is there. Structure is different only. Actually, this is a different type, but basic definition, structure. Again, subclassification is there. Basically, structure is different or not? This structure, same or different? Different. Simple definition. Complexes are having same molecular formula, but different structures are called as isomers. Complexes with the same molecular formula, but with different structures are called as isomers, and the phenomenon is called as isomerism. Let us start isomerism in complex compounds, how it was classified. Okay, right. You no need to draw the notes, write the notes. Okay, just listen. The JL is writing the notes. Good notes. Okay, you don't write. I given just to write the notes. It will save our time. Okay, just listen, all of you. Online students, no need to draw the notes. If you wanted your own handwriting, then take screenshots and copy later. Okay. Online students, are you getting? All of you. Isomerism. Isomerism is classified into in complex compounds. In complex compounds, isomerism is classified into two types: structural isomerism, structural isomerism, and stereoisomerism. Stereoisomerism. Structural isomerism and stereoisomerism. Right? In organic chemistry, same. In organic chemistry also classification is same, structural and stereo, right? In complex compounds also, Kirti and Sweda, we started isomerism. Isomerism in complex compounds is classified into two types: structural and stereo. Again, structural is classified into, don't write the notes, just listen, all of you, just listen. Ionization isomerism. Ionization isomerism. Ionization isomerism, linkage isomerism, ionization, linkage isomerism, solvate isomerism, it is also called as hydrate isomerism, hydrate or solvate isomerism, hydrate isomerism. Next, coordination isomerism, and coordination position isomerism, ionization isomerism, linkage isomerism, solvate isomerism, coordination isomerism, coordination position isomerism. This comes under structural isomerism category. Okay. Next, stereoisomerism. Stereoisomerism is classified into, tell me, in organic chemistry in first year we did, anybody, online students, how stereo is classified? Stereo, geometrical, optical, geometrical and optical, right? In NEET level, these two are most important. Means several times questions given from this optical and geometrical, and JE also, JE level also, because this is very easy. Structural is very easy, clear. So geometrical and optical are a little bit difficulty. That is also easy only, but we should remember some formats. Okay, Bhakti, you no need to write notes. We'll send the notes. Let us start first one, structural isomerism. All of you see latecomers. Isomerism in complex compounds. Like isomerism in organic compounds, we have isomerism in inorganic compounds. Under isomerism in complex compounds. Isomerism in complex compounds is classified into two categories: structural and stereo. Structural is classified like this and stereo is classified like this. Okay. First one, ionization isomerism. Ionization isomerism. Ionization Isomerism. Ionization. First I'll explain example, then I'll go to the definition. What is ionization, isomerism? What is basic condition for isomerism? Molecules should have same formula or compounds should have same formula. First we have to check whether compounds are satisfying basic rule or not. What is the basic rule? They should satisfy formula condition, same molecular formula. Okay. This formula, both are same only, no? Formula of these two complexes is same. One cobalt, one cobalt. How many amines? 5. Here how many amines? 5. How many chlorides in this? 1. How many chlorides in this? 1. One sulfate, one sulfate. So formula is same. Both are having same formula. Any difference? Right. What is the difference? In formula there is no difference. In structure it is difference. Okay. Okay. Difference is there in structure. Which type of difference also important? Clear? Right. Once dissolve this complex in water. Dissolve this complex in water. When we dissolve this, what we will get? Positive and Cl negative. Dissolve this complex in water. Positive and negative. SO4 minus. One is positive, one is negative. Okay. Actually, we should write like this here: +2 and -2, because sulfate ion charge is -2. Okay. You tell me. Both are having same molecular formula, but producing different ions when dissolved in water. Complexes having same molecular formula but produce different ions when dissolved in water are called as ionization isomers, and the phenomenon is called as ionization isomerism. Complexes with the same molecular formula but produce different ions. So different ions only, na? Here chloride ion is coming, here sulfate ion is coming, right? And another, actually this is basic definition. Some additional information to you. When we treat this solution with the AgNO3, you tell me Cl negative combines with the Ag to form AgCl precipitate, AgCl PPT. This is additional information only. Okay, right. When we treat this solution with BaCl2, we will get barium sulfate precipitate, BaSO4 PPT. Barium combines with sulfate to produce barium sulfate PPT, right? Chloride ion combines with the silver only. So when you treat this resulting solution with the BaCl2, there is no reaction. Clear? Why? Cl needs Ag plus. Cl combines with the Ag only. Clear? This is additional information only. And if you treat this with AgNO3, there is no reaction. Clear? You remember basic definition. What is basic definition of ionization isomers or ionization isomerism? Complexes with the same formula but produce different ions when they dissolved in water. Complexes with the same molecular formula, very simple definition, but produce produce different ions when dissolved in water, right? Molecular formulas would be same. How to identify ionization isomerism? Very easy. Outside coordination sphere, in one complex one ion is present, in other complex other ion is present. Over. How to identify ionization isomeric relationship? Outside the coordination sphere, different ions are present. Chloride ion, sulfate ion. Over. Formulas are same. Overall, formulas are same. But outside the coordination sphere, ions are different. Clear? Right. Online students, did you get this? Definition of ionization isomerism. Okay. And this is additional information, just you write. Okay. Proof. These reactions are proof. Shall we go to next type? Next example. You tell me, these two can be considered as ionization isomers or not? Can I consider these two as ionization isomers? Bhakti?
Yeah.
I can consider. Formula is same only, na? Platinum. Sorry. Because of that. 4 amines. Br2. Cl2. Formula is same. So we can consider. What happens when we dissolve this in water? Tell me, ions. 2 Br negative. If negative charge is -2, then how much positive charge should be present? Plus. Why I am considering 2 negatives? Because 2 Brs are there. So 2 unit negative charge. Cl2 and plus 2. Dissolve this in water. Platinum NH3 taken 4 times Br2 plus 2 Cl negative. One very important additional information. When we treat this solution with AgNO3, when we treat this solution with AgNO3, we'll get different precipitations. You have one lesson, qualitative analysis lesson. Okay, in that again we'll get not only in the qualitative analysis, this question came in organic purification. You tell me, what is the color of AgBr? You know already, AgBr color. Detection of halogens. Lessons test. AgCl, AgBr, AgA. అరే సార్, మీరు నిన్న చెప్పిందే మేము చదవలేదు, అరే మీరు ఫస్ట్ ఇయర్ అడిగితే ఎట్లా అని భక్తి లోపల ఆలోచన, అంతేనా? AgBr కలర్ pale yellow. AgCl white precipitate, white PPT. See, chlorine white precipitate, Br pale yellow, iodine yellow color. White, pale yellow, iodine is yellow color. In purification, first year organic compounds, right? Some extension to that isomerism. Basic definition is clear for everyone. Ionization isomerism and example list. Right, second one. What is second one? Ionization isomerism. Second one, linkage isomerism. No need to write the notes, I'll send, don't worry. Linkage isomerism. You only tell me by seeing this example. Nickel tetracyanide, not complete name, that is. What is its name? Complete IUPAC name? What is its name? Bhakti?
Tetracyanide 2.
Yes, tetracyanide nickelate 2 ion. Tetraisocyanide nickelate 2 ion. Molecular formula is same or not? 1 nickel, 1 nickel. How many carbons are there? 4 carbons. Taken 4. How many nitrogens are there? 4. How many carbons are there? 4. Taken 4. How many nitrogens are there? So orally formula is same, molecular formula is same, but what is the difference? Linkage. Complexes having same molecular formula, but the link with the central metal atom is different. Complexes with the same molecular formula, but link with the central metal atom is different. Here, ligand is linked with which atom? Carbon atom. Here, nitrogen. Link is different. Okay, write the definition. ఇక్కడ కూర్చోండి, కనబడుతుంది అక్కడ నీకు ఇట్రా. ఓకేనా? Complexes with the same molecular formula, but linkage with central metal atom is different. And one important statement, when linkage isomerism exhibits possible. When linkage isomerism is possible, which type of ligand is required for the linkage isomerism? What is the ambidentate ligand? Very important condition. Cyanide ambidentate ligand. When ambidentate ligands are present, then only linkage isomerism is possible. Very important condition. Complexes with ambidentate ligands. Complexes with ambidentate ligands only. Can you tell me some other ambidentate ligands? NO2, OCN, SCN. Ambidentate ligands information you have to remember. Okay, na? Obed, Surabhi. Obed and Surabhi. Adiba. Are you there, Adiba? Number of linkage isomers. What is the formula? What is N? N is equal to number of ambidentate ligands. I'll ask you this formula during calculation of isomers, geometrical, optical, total isomers. Note down the formula. When ambidentate ligands are present, number of linkage isomers. It is special formula actually, given here only. N is number of ambidentate ligands. Okay. Once look at this, all of you. Bhakti, tell me, Bhakti. How many ambidentate ligands are present here? How many ambidentate ligands are present here? How many? Taken twice. NO2 taken twice. ligands మనకు 2 ఇచ్చాం కదా. How many ambidentate ligands are there? 2. NO2 is a ambidentate na. Taken twice means 2. So number of linkage isomers. Tell me. Number of linkage isomers. Number of linkage isomers. No. How 16? నీ తలకాయ కాదు. ఇక 2 ఉంది కదా. ఎన్ని ఉన్నాయి లింకేజ్ ఐసోమర్? వాట్ ఈజ్ ఎన్ హియర్? 2 power 2 ఎంత అవుతుంది మరి? ఏమైంది మీకు ఇవాళ? అంత ఓకేనా? See, when we wanted to calculate total isomers, first we have to calculate linkage isomers. This is not the number for total isomers, right? This is the number only for linkage isomers. Isomerism arises, isomers arises due to linkage. Okay, total isomers formula is a different concept. Okay, we will discuss later. First you should know how to find number of linkage isomers. Due to the linkage, how many isomers will arise? I given that. Clear? Any doubt? Chlorine is not a linkage isomer. No, not ambidentate. Not ambidentate. NO2 is ambidentate. How many NO2s are there here? 2. So 2 to the power 2. So 4. Okay. Linkage isomerism is over. Next solvate isomerism. Solvate isomerism. Solvate isomerism. Solvate isomerism. Again, take one example. Here molecular formula is same. 1 cobalt, 6 water molecules, here also 6. One is inside, one is outside. 3 chlorines, 3 chlorines. 1 chlorine is inside, 2 chlorines are outside, right? Compounds having same molecular formula but differ in number of water molecules or solvent molecules which acts as a ligands. Here how many water molecules acting as ligands? 6. Here how many water molecules acting as ligands?
7, 6,
5 only, inside. Okay. Formula is same only, molecular formula is same only. But water molecules, solvent molecules which acts as a ligand are different. Here 6 water molecules acting as ligands. Here 5 water molecules acting as ligands. Complexes with the same molecular formula but differ in the number of water molecules which act as ligands. Differ in the number of water molecules which act as ligands. Here how many water molecules are acting as ligands? 6. Here how many water molecules acting as ligands? 4. Complexes with the same molecular formula but differ in the number of water molecules which act as ligands. Same molecular formula. I'm not writing complexes with same molecular formula, shortcut definition. Complexes with same molecular formula but differing H2O molecules or solvent molecules. Differing H2O molecules inside and outside the coordination sphere. Here inside how many water molecules are there? 6. Here inside how many? 5. Here outside is there any solvent molecules? No. Here outside?
yes.
Okay. Can we consider these two as ionization isomers? Can we consider these two as ionization isomers? Can I consider these two as ionization isomers? No. If we dissolve this in water, we will get chloride ion. Here also we will get chloride ion. We cannot consider these two as ionization isomers. Can we consider these two as linkage isomers? For linkage isomerism, what is the needed? Ambidentate. Is there any ambidentate ligand inside it? No. Is there an ambidentate ligand? No. So solvate isomerism. I'll give you one example in which two types of isomerism will possible. Okay. Coordination isomerism. Once see this, you tell me what is its name? General, I am asking. What is its name? No. Common name. Nestlar's reagent. You tell me, in this, how many coordination entities are present? How many spheres are present? One sphere is present. This is positive or negative? Negative. Here positive is not coordination sphere, but here negative is coordination sphere. Here positive is coordination sphere, negative is ionization sphere. Means if you take one complex, mostly one sphere only present. Mostly one square bracket only present. Clear? But the complex in which both positive part and negative part appears as coordination spheres, one bracket, second bracket. In this complex, positive part is not appearing bracket, square bracket. Which part is appearing? Negative part, coordination sphere. Here positive part is appearing as a bracket, not negative part. But in some complexes, both negative part and positive part, or positive negative vice versa, appears as spheres, square brackets. Clear? So that is the condition. Coordination isomerism exists when both positive part, means here one bracket, and negative part appears as square brackets, are present as coordination spheres. Here in this case, positive part is not appearing as a sphere. In this case, negative part is not appearing as a sphere. But in some complexes, what happens? Both positive part and negative part appears as a spheres. In that complexes, coordination isomerism is possible. That is the first condition, right? First, I will give that condition. The complexes in which both positive part, means cationic part, positive part and negative part appears as coordination spheres will show coordination isomerism. Now coming to the definition. Basic condition is we should have coordination isomers, means both positive part and negative part should appear as spheres. I have given just a condition only. Now I will come to the definition. See, amine, which ligand?
Neutral.
Neutral. Chlorine. So this is negative, halogen is negative. So you can imagine this part as a negative, this is a positive, like that. Okay. This total structure is a complex, right? Total unit is a complex. Before that, in positive part, in this example, I erased that. Sorry. K2HGI, for example, positive part is potassium, right? That is not a square bracket. Here positive part is square bracket, negative part also square bracket. Clear? Now coming to the definition. See, I am writing one isomer for this. You tell me the difference between these two. What is the difference between these? How I wrote this? By doing which operation I did? How I wrote this? What I did? Interchanging the ligands. Interchanging the ligands. The isomerism which arises due to interchanging the ligands between the coordination pairs is called as coordination isomerism. That is the definition. The isomerism which arises due to interchanging the ligands between the coordination pairs. CO present here only, right? Only CLs will come this side. Cr present here only. Ammonia ligands will come this side, right? The isomerism which arises due to interchanging of ligands between coordination pairs, right? Short form coordination pairs. So whenever you observe two square brackets, the mostly that example will comes under coordination isomerism. Okay. And condition is positive part, negative part should appears as square brackets. Why we are considering this as a negative part? Halogen is negative. So remaining counter part is positive. Okay. Next, coordination position isomerism. Coordination position isomerism. Coordination isomerism is different. Coordination position isomerism is different. Coordination position isomerism. This type of isomerism is observed in the complexes which are having bridges. This ligand is acting as a bridge in between these two metals. Bridged complexes. Coordination position arises in bridged complexes. In between two metals, one ligand present as a bridge. Right. See. Shift one amine to this side. Coordination position. Within the coordination sphere, position of ligands is different. Position of ligands. See, here how many amines are attached to cobalt? Here how many amines are attached? 4. Okay. Now what I am doing, I am changing the position of 2 amines to this place and 2 chlorines to this place. I am changing the just positions. They are interchanging their positions. 4 amines are sitting in this position, there are 4 chlorines are sitting in this position, they are changing their positions, places, right? Take to this side and to this side. CO, NH3 taken twice and Cl2, 2 chlorines shifted here, OH, CO, NH3 taken twice, Cl2 plus 2. This is not that much important, but just have a look at this. Coordination position. In between these two, what is the difference? Tell me. Both are having same formula, but what is the difference? How can we say the difference?
Position of ligands is different.
Position of ligands is different within the coordination sphere. That is called coordination position isomerism. Complexes. This is complex, cationic complex. This part is cationic. This is also cationic complex. Both are having same formula. This formula and its formula same, but difference is position of ligands. Same molecular formula, but different position of ligands within coordination sphere. Position of ligands within coordination sphere. Yes, bridged complex only it is possible. Can we call these two as ionization isomers? No. Linkage isomers? No. So only the possibility is position. Why? Because you are changing the position. Position of amines. Here amines are sitting at this place. You are changing their position. 4 chlorines are sitting one place. You are changing the position. Within the coordination sphere, you are changing the positions. So coordination position isomerism. Got it? Next, keep waiting. Stereoisomerism. Stereoisomerism, we will calculate later number of structural, geometrical, optical. Next, stereoisomerism. Online students, are you there? Others? Ubed. This is very important. See, if you didn't get that structural isomerism, nothing will happen, because probability is very less to get the question, but geometrical, optical are very, very important. Means stereo is very, very important and easy compared to that. Here in structural, what is the main drawback? Understanding the definitions and identifying the example is difficult. But here understanding definitions, everything is easy only. Okay, important and easy. That is not important and difficult to understand, but it is very easy and important. Stereoisomerism. Stereoisomerism is classified into how many types? How many types? 2 types. Geometrical, optical. Geometrical isomerism and optical isomerism. Once look at this. Geometrical isomerism in coordination number 4. Geometrical isomerism in coordination number 6. With coordination number 4, very, very important, tetrahedral complexes. Tetrahedral complexes do not show. Highlight this. Tetrahedral complexes do not show geometrical isomerism. Tetrahedral. What are the possible geometries with coordination number 4? With coordination number 4, what are the possible geometries? tetrahedral and square planar, tetrahedral and square planar. Square planar complexes will show. So geometrical isomerism. So most important point, tetrahedral complexes do not show which isomerism? Geometrical isomerism. How to find tetrahedral complexes? See, that is your order, online students, especially incoming second years. How can we know about the given complex is tetrahedral or square planar? First they started isomerism, right? Then how can we find which is tetrahedral, which is square planar? How to find hybridization? Yesterday, based on yesterday's. Correct? But in your syllabus order is zigzag. Clear? Based on the idea of tetrahedral and square planar, then you can select which will show geometrical. Okay? That's why I explained VBT, hybridization concept. When complex is tetrahedral, that do not shows. Even though the one formula, structural condition is there, even though it satisfies structural condition, but it won't show GA. Because when it comes under tetrahedral, it won't show isomerism, geometrical isomerism, right? Okay, final conclusion. With coordination number 4, which isomers do not exhibit geometrical isomerism? Tetrahedral. Square planar will show. Coordination number 6, all types. Octahedral only. Structure is octahedral only, it will show. There is no any exception here, right? With coordination number 6, only we have one geometry, octahedral geometry. I explained in the last class how to find hybridization, right? Optical isomerism. This is general structure, okay? Again, we have exceptional, but you should have idea about this basic things. Optical isomerism. Optical isomerism with coordination number 4. Square planar. Square planar complexes never shows. But here, square planar complexes only shows geometrical isomers. Okay, reverse order. You know already, according to first year organic, you tell me condition for optical activity, presence of chiral center or absence of symmetry element. Okay, planarity. If planarity is present, then optically inactive. Planar molecules never shows optical activity. Do not show. Planar complexes do not show optical activity. Optical activity. Square planar. Tetrahedral complexes will show, but one condition, on one condition. TD, tetrahedral complexes shows optical activity when, very important, when tetrahedral complex is present in this format: M, A, B, C, D, E, F, I. Only 4, M, A, B, C, D. Okay, 4 different ligands are present. Then only tetrahedral complexes exhibit optical activity. Very important point. Okay, here only optical isomerism is possible. If tetrahedral complex is not present in this format, it do not exhibit. ABCD means 4 ligands should be different. Okay, for example, nickel is there. Nickel should surrounded by 4 different ligands: nickel, chlorine, bromine, iodine, water molecule, like that. When 4 different ligands are present in tetrahedral complex, that will exhibit optical isomerism, optical activity. Exceptional case means conditions are there, that's why I given this. And coordination number 6 will show directly, right? Shows optical activity. So basic idea, square planar complexes will show Zi. Square planar complexes never show optical isomerism. Square planar complexes show geometrical isomerism. Square planar complexes do not show optical isomerism. Tetrahedral complexes do not show geometrical isomerism. Tetrahedral complexes show optical. When MABCD type, right? Read this chart first. Next heading, geometrical isomerism. Geometrical.
Condition number 6 for geometrical isomerism.
Huh? It shows. Online students, are you getting? Hello? All of you? Adiba, Obeid, Aisha, Ketura పాలుతున్నారమ్మా ప్రాజ్ఞిక కీర్తి అలవాటు అయిపోయింది. కీర్తి ప్రాజ్ఞిక కేతుర ఒక బ్రాండ్ అనమాట. మూడు కీర్తి కేతుర ప్రాజ్ఞిక ముగ్గురు వచ్చేస్తారు ఇప్పుడు. Aisha, are you getting? Hello, Aisha? Right. Adiba, you? Adiba. Geometrical isomerism. Let us start with coordination number 4. Write the notes neatly, okay? And close it and never open it. Before exam day only open it. Second years. Coordination number 4. Monodentate or unidentate. Monodentate or unidentate. Monodentate or unidentate. Bidentate. Bidentate. By tomorrow everyone learn these formulas, okay? Second years and outgoing seniors also. Red color do not show, means orange. MA4 type complexes do not show geometrical isomerism. MA4. A4 means all ligands are same. Homoleptic complexes. Homoleptic. This is homoleptic. Homoleptic means, what is homoleptic, Sweta? Same kind of ligands. Example, nickel Cl4, 4 chlorines. Ma4 and Ma3b type. Ma3b type, plus or minus n. That is charge over the ligand, plus or minus n. Do not show. So red color, pink color do not show. This category do not show. Or do not exhibit or do not show geometrical isomerism. This is very easy. Well, it is very easy. If you remember the formats. Which format shows GI, which format do not shows GI? Vaishnavi, MA4 means, tell me. Okay, give me an example. Nickel, NiCl4, correct? Copper H2O taken 4 times, correct or wrong? 4 similar ligands, so do not shows. Statement type questions. Homoleptic complexes do not show geometrical isomerism. Correct statement. These are monodentate category. A is a monodentate ligand because category is monodentate. Yellow signal, green signal ante show chestadi kan green pen use chesthe etla untundo mari vallaku.
So homoleptic kuda show cheyandi.
ఇదే కదా ఇచ్చింది నీకు. ఇదంతా రెడ్ కలర్ అంతా షో చేయదన్న, ఇది పింక్ కలర్ మొత్తం. ఇప్పుడు ఇది మనకి గ్రీన్ కలర్ షో చేస్తుంది.
సార్ ఇప్పుడు హోమోలిప్టిక్ కార్బన్స్
కాదు, బట్ అందుకనే దాని కింద రాయాలి, నేను దీని కింద రాసా ఉంది.
హోమోలిప్టిక్
And
ఇంకా
heteroleptic also. Heteroleptic with condition, but homoleptic always. That is the main. This also heteroleptic also, but when it is in the form of A3B type. Heteroleptic do not shows when A3B format. Homoleptic always. Heteroleptic when it is in A3B format. Okay? Show చేస్తుంది, అది ఇవ్వబోతుంది ఇక్కడ. ఓకే, M A2B2, this is heteroleptic, right? Heteroleptic with this category only, A3B category only. A2B2 will show. M A2BC will show plus or minus n, charge is plus or minus n. Having idea about these formulas is very important. That idea helps you to answer directly. Okay, MABCD, all are different ligands. Shows GI, geometrical isomerism. Ma2B2 means, for example, nickel Cl2 Br2, A2B2 category, like this. Okay, Cl2 bromine iodine, this category Bc, all are different means nickel, chlorine, bromine, iodine, fluorine, all are different. Nickel, chlorine, bromine, iodine, all are different. Online students, are you getting? We'll discuss what is the reason for this, why A4 do not shows. Online students, please don't be silent. I will afraid about your silence. Follow అవుతున్నారా? Are you getting online answer? Bidentate ligand. Say one bidentate ligand कितने? Bidentate ligand. Glycinato, alaninato, DMG, oxalato, acetyl acetonato. ఇంకా ఏమన్నా? Super. Bidentate ligands do not show category. అప్పుడే అది కాదు, జిఎల్వై షో చేస్తారు. MAA category do not shows. AA means, what is the meaning of AA? Similar donor atoms. AA means, in square bracket I wrote AA means, look at this all of you, CH2, NH2, what is its name, Kirti? What is the name of this ligand? Ethylene diamine or ethane 1,2 diamine. Okay, ethane 1,2 diamine. Some second year students only examples because they didn't listen, but it happens, they learn complex compounds at the end of the second year. Actual learning they start at the end due to several reasons, improper teaching in the college, everything. Okay, for you I am saying especially. Okay, don't neglect the ligands list. ఇథిలిన్ డయామైన్ వాళ్ళు ఎంత సఫర్ అవుతున్నారో చూడండి ఇప్పుడు, పాపం నైట్ అవుట్స్ చేస్తున్నాయి, గుర్తు రావట్లేదు శాతకి. ఇథిలిన్ డయామైన్ ఆర్ ఈథేన్ 1,2 diamine. See, donor atoms are same, NN, Kirti, NN, similar donors, that's why I took AA. Means in this ligand 2 donor atoms are same, that is the meaning for it. Clear? For example, if I write okay, this color hey, oof. M A B taken twice plus or minus, you can keep this plus or minus if I forget. Okay. M A B taken twice means
Different term.
the bidentate ligand in which two donor atoms are different. Glycinato, we know glycinato structure CH2, C double bond O and NH2. What are the donor atoms?
Okay. Yeah.
Oxalator same వస్తుందమ్మా. Glycinato బోర్డు ఉందా వీళ్ళకి? N and O both are different donor atoms, right? That's why I wrote AB. What is the meaning of AB? Means this is a bidentate ligand. Bidentate ligand. In square bracket, one bidentate ligand is present. In that, two are different donors. Square bracket is inside square bracket. AA is present. AA is a bidentate ligand with two similar donors. Clear? Yes, tell me. Bidentate ligand A dash. We can use like this also. If you get any confusion, see all of you. She's saying that use some other different. Let us use this. AB. AB. Square bracket AA. Square bracket AB. Okay. Clear? Tell me. This side what I have to write? This color. Do not exhibit. Do not exhibit. One more example also there here. Just a second. One more example also there. MAAB2 MAA. I didn't write taken twice. Taken twice. MAABC do not shows. I'll give examples for each and every category. Okay. Today what you have to do? Learn the chart. After discussion with some examples, then you will get clarity. Do not show. Inside a square bracket, one bidentate is present and outside monodentate is present. Okay. Again, you will get the confusion. No? Then, oh. You can continue with the capital letters only, nothing will happen, okay? But small letters, monodentate. We can write B2, capital B2 also. After discussion of examples, there is no differentiation with small letter or capital letter. Everything is same. In that category, MAB2 will show ZA. Okay. Monodentate, bidentate category with the coordination number 4. Okay. Next, write fastly with the coordination number 6. Coordination number 6. So that we can start examples directly tomorrow. Coordination number 6. Coordination number 6 again, two categories. Monodentate and bidentate. Monodentate and bidentate. Monodentate do not show category. MA6 do not shows. S or minus L. MA5B do not shows. First do not show category. Just tell me. Okay, Ketara. And which shows? M A2 B2 C2. MA3B3, MA3B3. One special type, actually geometrical isomerism shown by MA3B3 type complex is called as facial and meridional, a separate type. Tomorrow I'll explain facial and meridional. We'll discuss tomorrow what is facial meridional. Direct question, which of the following complex shows facial and meridional? MA3B3 category. Best example, once look at this, Cl3Br3. Look at this. This comes under which category? Tell me. Which category? MA3B3. MA3B3 category. Clear? Tomorrow we'll discuss example for each model. MA3B2C will show. MA3BCD will show. MABCDEFGHIJKLM and Rayana 6 1 2 3 4 5 6 only ABCDF coordination number 6. Okay, one simple logic. See, Bhakti, if you remember these two, remaining way shows. Very simple logic. With coordination number 6 and monodented, see the trick. If you know which complexes do not show, remaining all will show. Which complexes do not show? A6, A5B. Remaining will show. Very easy. So, this is better. Remember the ligand complexes which do not show. Then very easy to identify the complexes which show. Bidentate ligands. With the bidentate ligands, MAA taken thrice do not show. Questions will come based on these formats only. For example, cobalt EN taken thrice in ethylene diamine. What are the donor atoms? What are donor atoms in ethylene diamine? In ethylene diamine, what are donor atoms? Nitrogens. So, can I write ethylene diamine? This ethylene diamine is example for this. AA represents two similar donor atoms. Sorry, capital letters use cheddama. A. Okay. Do not show category. Do not show category. MAB taken thrice shows. Plus or minus n charge. MAB taken thrice shows systems. MAB taken twice C2 shows. MAA taken twice B2, very important model. See, MAA taken thrice do not show, but MAA twice B2 type will show. B2 type will show. Clear? And this is first day you will feel difficulty to remember how many formats I have to remember. Very easy concept in the complex chemistry. Okay? Now you are free only, no? So read it. Because next exam also online only, I think. Mostly. So spend 1 hour time you will get. If you learn these formats or formulas, then it is very easy. Next class is very easy. MAA taken twice BC. And one more simple logic. If you remember this one simple category, remaining all will shows geometrical isomerism. In bidentate in octahedral complexes with coordination number 6, which format do not shows? MAA with similar ligands do not possible. Remaining all will shows. Okay? Right. We'll continue tomorrow. Any doubts? Aisha, Ubaid, all of you? Is everything okay? Ketura? Ketura. Practice this, okay? Then you will get tomorrow's class easily.